Today's lesson is on function inverses. So let's go over a couple definitions before we start. First of all, a function is a relation where each input only has one output. So the input is the x and the output is the y. So each x only has one y. So this is what we mean. This is a table, and we just list points in a table like so. So this is just saying the same thing as 3, 4, 5, -6, 7, 8, 0, -6. These are just coordinates. So we could graph those, right? That's called a table. So notice that each input or each x value only has one y. Okay. This is called mapping. So in this example, this is 2, 4, -3, 2, -1, 1, and 0, 1. That's how you read this. So here, again, every x value only has one y value. It's not 2, 4, and 2, 2. That would not be a function if we had this x or this term going to 4 and going to 2. That would not be a function. Notice each of these x's only goes to one y. That's mapping. And then here, these are a few functions. So this is algebraic functions. So those are a few functions that we can talk about. So all of those examples are functions. Now let's look at the inverse of a function. So a function, these are some examples. Inverse of a function, those are just functions that are reversed. Okay? So let's talk about what this is. So the notation, notice f of x comes up again. So f of x is the same thing as y. So f of x, the inverse of f of x, looks like that. And that's just called f prime of x. That just means that this is the inverse of f of x. Okay, we're going to talk more about this, but just know that every time you see that -1 up there, that means the inverse function of the original function. So again, just like I said, this just means the inverse of f of x, and this notation, all that means is the inverse of g of x. Now be careful, because this, sometimes it's commonly mistaken for 1 over f of x. These two do not equal each other. So this -1 doesn't tell you to put it on the denominator. Okay, so these are not equal. All this means is it's the inverse of f of x. Okay, so let's go over some examples. So given a function, so remember the functions in the last example, the first example that we did, determine the inverse. So if we're given a table and these are our points, it says determine the inverse. Okay, well, remember what we said about inverses, that it's just a function that's reversed? We're going to reverse these points. So what would the inverse of this be? Instead of 5, -3, the inverse, so this is just saying that this is f of x, the inverse of the function would be -3, 5. Do you see how I just switched these around? So this is the original, and this is the inverse function. So -2, 6 would be 6, -2. 4, 6 would be 6, 4. So this is the original function, this is the inverse function. Okay, let's look at an example of mapping. So if this is your original function, again, that's x first and then y, and this is just telling me 2 goes with 9. -1 goes with 6, 6, 8, and 5, 6. So let's look at determine the inverse. So if this is f of x, my inverse is f prime of x. This is the inverse of f of x. So again, remember we had 2, 9. Now we're going to have 9, 2. Oh, okay, I guess I wrote these first. So see how we had 9, 8, 6 in y? 9, 8, 6 now goes in x. You see how we had 2, -1, 6, 5 in x? Now that goes in y. But we're going to connect the same point. So 2 still goes with 9. But instead, now 9 goes with 2. And instead of -1, 6, it's 6, -1. 8, 6. 6, 5. Do you see how these are just reversed? So remember, The inverse of a function is just a function that is reversed. So finding the inverse of functions in tables, mappings, and ordered pairs is simply switching the x and y values. All we did here, and if we had ordered pairs, which is just, -3, 5 or something, you would just switch it around. So notice these are just flipped around. It's just switching the x and y values. So that's if you have one of these. But if you're trying to find the inverse of an algebraic function, you have to do a couple different things. So here's some steps. First, you have to change f of x to y. So if you have an f of x, change it to y. Remember, those two are the same. You want to change that to y first. Then you're going to switch x and y. Then you're going to solve for y. And then you're going to change y back into back into the inverse function of f of x right here. So you want to change f of x to y, and then you're going to change y back to the inverse of the inverse function. Okay? So let's do some examples to see how this works. So find the inverse of the given functions. So the first one here, f of x equals 2x squared minus 7. Remember, the first step was to switch this to y. So we're going to say y equals 2x squared minus 7. Now we're going to switch x and y. That's the next step. So it's x equals, notice all I did here was switch y to x, and I switched x to y. And I have to solve now for y. So if I'm solving for y, the first thing I'm going to do is add 7 to both sides. That cancels out on the right side, and we have x plus 7 equals 2y squared. Now I need to get the y squared alone. And so to do that, I'm going to divide each side by 2 first. That cancels out. I'm left with x plus 7 over 2 equals y squared. Now, do you remember how to get rid of a squared? What's just like the opposite of here, this is multiplying, 2 times y squared. So we divide. The opposite of square functions, to get rid of a square, is to take the square root of both sides. That cancels this side out. So the square root cancels out the square. So we're just left with y. But when we take the square root of a function, we need to make it plus or minus. The reason for that is because if we square a negative, it turns into positive, right? Like if we had -5 squared, isn't that positive 25? And if we have 5 squared, isn't that also positive 25? So that's why when we take the square root, like if we were going to square it again, we'd get the same number no matter if it was negative or positive, because when we square anything, it's going to be positive. So whenever you take the square root of something, you want to give that plus and minus. Okay, so that's x plus 7 over 2 equals, and again that cancels out, so we're just left with y. So don't forget, whenever you take a square root, you're going to put plus or minus in the front. Now the last step is to switch that y back to the inverse function of f of x. Because remember, we started with f of x, now we're the inverse function of f of x, and this is your answer. Okay, so number 2. If we have g of x equals 9x plus 3, the first thing we're going to do is we're going to switch this to y, so y equals 9x plus 3, and then we're going to switch the x's and the y's. Now we're going to solve for y. So what's the first step to solve for y? We're going to subtract 3 from both sides. That cancels out on the right, and we have x minus 3 equals 9y. What's the last step? We're going to divide by 9. So now x minus 3 over 9 equals y, and the very last step is we're going to switch the y, we're going to change it back to the inverse function of g of x. Okay, and then this just stays the same. So that's your inverse function of g of x. So this time, notice it's already a y, so we don't need to switch it to y, right? That's the first step, is to change g of x or f of x to y, but here we're starting with y, so the first step is actually going to be taken care of, so we're just going to switch the x and y now. So notice x, so let me go back a step. Before I do that, notice all I did was I switched the x and y here, so I made this x a y, I made this y an x. So now we're going to solve for y. Now, the easiest way I think to do it is to put this x over 1. If I put this x over 1, can't I just multiply? I can do proportions, right? So 3y times x and then 1 times 10. So 1 times 10 is just 10. And 3y times x is 3y times x, right? We're just going to put them all together. Now, my goal here is to get that y alone, right? So I'm solving for y in all of these. So I want to divide by 3x. Remember how we did this with exponentials and logs? How when we were trying to get a variable by itself, that x by itself, it was x before instead of y, we would divide by the first, because this is all multiplying. So it's easiest just to do it all in one step. So we're going to divide by 3x, because notice now that 3 and that 3 cancel, the x and the x cancel, so all we're left here with is y equals 10 over 3x. Now the very last step is to change this to, like here we change, instead of g of x, we change it to the inverse of g of x. But the inverse of y, because we started with y, we didn't start with f of x or g of x, we're just going to put that little 1 there. Do you see how here it was like g, the inverse of g of x? This is the inverse of y. So that little 1 in between here, up here, that's the same thing here next to the y. That's your final answer. Okay, so determining if two functions are inverses graphically. So what if we have graphs instead of just a function? So since finding inverses consists of switching x and y, graphically we use the line y equals x to determine if it's an inverse, looking at y equals x as the line of reflection. Okay, so what in the world does this mean? We're going to take a look and you'll see how this all comes together. So for example, if we find the inverse of f of x graphically, I'm going to give, so this is your function, okay? This is f of x right here. Okay, so here I just drew a function. So this is what you're given. You're given this, okay? Since the finding the inverses consists of switching x and y, we're going to use y equals x. Now, y equals x is the same as y equals 1x plus 0. Do you notice that this is just a line? If I put a 1 in front of that x, it doesn't change anything, right? And if I just decide to add 0 at the end, if I'm adding 0 to something, it doesn't change anything because it's not, I'm just adding nothing. Now, doesn't this look like a linear equation? This is a linear equation, so how would we graph that? Well, we'd start at 0. Remember, this is your y-intercept, so we'd start here. And remember, this number in front of your x is always your slope. So your slope is 1 over 1. So rise 1, run 1, make a point. Rise 1, run 1, rise 1, run 1, and then we can also go down the other way. This right here, this line is called y equals x. So whenever you're seeing y equals x, all this is asking you is it's saying, okay, this is your function. This is the line y equals x. How would you find the inverse? Well, picture folding this line right here over y equals x. Wouldn't it look something like this if you folded it? That's exactly what we're doing here. We're saying, okay, this is the line that we're gonna do the reflection of, and we're gonna reflect this. So if you're looking in a mirror and this is your mirror, it's gonna look something like this. Now, how do we find this out? Well, we just switch the points. We know one of them is 1, 4, right? So, and then -2, 1. So my line of reflection, instead of -2, 1, it's going to be 1, -2. Instead of 0, 3, it's going to be 3, 0. And instead of 1, 4, it's going to be 4, 1. Do you see how I just switched the points? And now that is my line of reflection, and it looks like it's being reflected over y equals x. So that's called my inverse function, which remember it looks like this. This is the notation of the inverse function. Okay, given the graph, determine the values. So here we have, I just drew a graph, so this is the given, it's h of x. And we're going to take a look and see what h of 0 would be. So if this is your regular graph, just h of x, remember that this just means h of x. So what am I replacing x with here? I'm replacing x with 0. This is telling me x equals 0. So when x equals 0, what does y equal? 2, right? When x is 0, y equals 2. So your answer here is 2. All this means is if x equals 0, because we're replacing the x here with 0, what does y equal? Well, y equals 2. What if we had h of 4? H of 4 is the same thing as saying if x equals 4, what does y equal? So if x equals 4, 1, 2, 3, 4, what does y equal? Well, y equals -1. Okay, now what if we had the inverse? Remember, this is the inverse function of h of x. So instead of this telling me that this is my x, what do you think that this is telling me? Usually when we just a normal function, this is saying x equals 0, this is saying x equals 4. This time when you have an inverse function, it's saying y equals 3. So if y equals 3, 1, 2, 3, what does x equal? Well, x equals 1. So this is saying if y equals 3 this time, what does x equal? X equals 1 on your graph. So here, if we have the inverse function of h of x, this is the inverse function because that -1 up there. This is saying if y equals -1, what does x equal? Well, if y equals -1, notice x equals 3 different things here, doesn't it? So if y equals -1, you're just going to go across and see where y equals -1. Well, y equals -1 here. It's -2, -1. So -2 is one of your answers. Okay, y also equals -1 over here, so 2, -1. Well, I guess it's not exactly 2. So this point right here, since it's not an exact place, like this is a 4, right? So if we went 1, 2, 3, 4, -1, y equals -1 at 4 as well. And then also at this point, so let's add that because it's going to be some decimal. But let's just say that that is, I don't know, 2.3. Of course, on like homework or something, that would be more obvious, and I would have to label that instead of you just guessing. But we're just going to say and 2.3. So there's actually 3 different y values there. I'm sorry, x values there. So there's an x at 2, -1, 2, -1, -2, -1, and 4, -1. Okay, and I just said that this point right here was about 2.3. All right. So this inverse function means we are looking for the x values at the given y values. So this is just telling you there's a y instead of an x, and now we're going to be looking for the x values. That's all that means. So let's do one more example. If this is your f of x line, let's first look for the inverse function for -2. So this is telling me that y equals -2 because it's an inverse function. So where does y equal -2? Well, the only place is right here. So y equals -2 when x is 0. What about f of 4? So that means this is not an inverse function, so this means x equals 4. Where does x equal 4? Well, x equals 4, 1, 2, 3, 4. So what does y equal there? 1, 2, 3. So that means y is 3. Okay, again, this is just a regular function. So we're looking here at f of x. And if x equals -3, 1, 2, 3, what does y equal? Y equals 1. Okay, so this is an inverse function, which means this is y. So when y is 2, what does x equal? Well, x equals this point and that point. So if y equals 2 across here, so that's going to be -1, -2, -3, -4. So x equals -4. And x also equals 1, 2, 3. So negative 4 and 3. So here at 2, x equals negative 4, and at 2 for y, x equals 3. Okay, again, this is the inverse function, so that means that this is y. So when y equals negative 1, notice we have two different points for x. We have negative 1 and we have positive 1. Okay, last one. Now this is a normal function again. Okay, so we're just looking at this function. This is saying x equals negative 5. If x equals negative 5, 1, 2, 3, 4, 5, what does y equal? Y equals 1. Okay, and that's it.